Hi Year 11, this is a video on the line of best fit within data and also linear regression. So the line of best fit is a straight line drawn through the centre of a group of data points, which I'm sure you all know already. To draw by hand, you must first calculate the mean point. We plot this on the scatter plot and then draw the line of best fit, and it has to go through that mean point. So when you have a line of best fit, you can use it to find estimates about the data. There are two types of prediction: interpolation and extrapolation. So interpolation is when it's inside the data range. So that means that the value you're looking for is within the range of data you've been given. Extrapolation is outside the data range. So say if our data went from 0 to 10 and it wanted us to predict 12, then that's extrapolation because it's outside the data range and we often don't consider it. So an answer in IB exam would state unable to estimate as outside the data range. So example 1, we've got this table shows the total fat and total calories in fast food. We're going to find the mean of grams of fat, find the mean of calories, construct a scatter plot, and then draw a line of best fit. And so to do this, I'm going to show you how to do this on your calculator as well at the same time. And then obviously, I'll show you how to do your scatter plot on your GDC, and then you need to copy that down yourself and then draw a line of best fit through it. So to work out our mean on the calculator, remember we've got to input the data into the spreadsheet, and then we can calculate the mean from there. So what you need to do is you need to go into your spreadsheet, which is the green button, and enter your data. I've already done it, so I'm not wasting time on the video. And you'll see here I've entered the data. Now, if you want to draw a scatter plot on your graphics calculator, you also need to name the columns. Otherwise, you can't do that. So I've enabled them fat and calories to match what the table is about. And now to work out our means, just the same as what we did before with statistics, we go menu, statistics, stat calculations. Now because we now have two variables, we've got fat and calories, we can do this in one step to make it a bit quicker, and we can go to two variable statistics. Now on here we will put our X and Y, so you can put column A, or if you see in here, if you've labelled something, you'll have that information. So our X is fat, our Y is calories, and then just double check that your result column isn't going to overwrite any of the data you've already got. Press OK, and here we have our information. So our mean of X, which is our fat, is 22.454545, keeps on going forever. And if we scroll down, you will eventually find you get to your Y mean, which is 457.27. And if you look right at the bottom, it gives you the full number here, and you'll see it's 0.27 recurring. So there are our means of our X and Y, and that is what makes our mean midpoint. So when we draw a scatter plot, so on your calculator to draw one, you go back to the home page, and then you're actually going to click the pink button here. And now this isn't your scatter plot. You see here, it's got click to add variables on your X and Y axes. So if I click here, I want my X variable to be fat. I want my Y variable, so go to the Y axis, to be calories, and it will draw your scatter plot for you. Now what you're going to do with your mean midpoint, so you take your mean of X, your mean of Y, and you plot that point on here. So we had 22.45 and 457.25, so it would be in this area somewhere here. But obviously when you draw your scatter plot, you will plot that point, and then you're going to draw a line of best fit through that. If you want to see what your line of best fit should look like, on your scatter plot here, you can go menu, and if you go to analyze, there is regression. And in here, we want a linear line, we want a linear regression, so click that one, and it will input a linear regression line for you. And so you can double check that what you've drawn is similar to what you have on here. So if we go back to our notes, I will show you what your scatter plot with your mean midpoint plotted should kind of look like. So here's the information we found, which is the means and the scatter plot. And you see that green dot on the scatter plot? That is the mean point that I was talking about that was plotted. And then the line of best fit was drawn through that. Okay, so next we've got the regression line equation, which is the equation of the line of best fit, and we can also be called the regression line. And we often write in the form y equals mx plus b, or y equals ax plus b. Now I'm telling you those two ways because your calculator uses the y equals mx plus b in its programming, and IB exams often ask for y equals ax plus b. So you just have to remember m and a are the same thing. And we find these values on the graphics calculator, and in the IB, in the syllabus, you are only expected in an exam to do this through your GDC. If you were once again to do like an IA on it, then you will need to do it by hand. So example 2, as a car's tyres become worn, it uses more fuel to travel the same distance. The table shows the age of the tyres and the number of kilometres the car travelled on 1 litre of diesel. We're going to write down the regression equation, interpret the meaning of the constant value, interpret the meaning of the gradient, and then estimate the distance the car would have travelled when the tyres were 3.5 years old. So A, write down the regression equation. So I'm going to show you how to do that now on your graphics calculator. To find the regression equation on the GDC, first step is once again to enter your data. So open up the spreadsheet and enter the data. And so when we have data like this, which is 2 rows of data, the top row is X and the bottom row is Y. So we're going to enter it into the spreadsheet, the information, so now we have our information in here. Because we're not going to draw a scatter plot, we don't need to label the columns, but you can do if you would like. Now to find the regression equation, we're going to go to the same spot that we did when we did the R value last lesson. So your menu, statistics, stat calculations, but this time we want linear regression. We want a regression line, so we're going to click that option there. And once again, we just put in the columns we want. So if you've labelled them, you can find the name. If you haven't, just go A column, B column, and then just make sure your solution is in C or D, so it doesn't overwrite your data. Press OK, and here we go. So we want an equation of y equals mx plus b. So our gradient, our m, you see is right here, negative 1.34, and our b value is 21.2733. And then we just input that into our equation. We'll go back to the notes and you'll see how that looks. And so that regression equation that we found was y equals negative 1.34x plus 21.3. Okay, so for B it says interpret the meaning of the constant value. Just think about if the age was 0, it would make this first part of the equation 0. So if we had 0 in here for x, so at the start, when it's 0 years old, it would equal 21.3. So what it is saying is that at the start, with brand new tyres when they're 0 years old, you would probably have travelled 21.3 kilometres on 1 litre of diesel. So we just want to write that in some sort of sentence. So I will say with brand new tyres, the car would probably travel 21.3 kilometres on 1 litre of diesel. Okay, C, interpret the meaning of the gradient. So determine the meaning of M. And so because it's minus 1.34, it means it's going down, the gradient's negative. So it means as the distance is decreasing, age decreases. So as a sentence, we just write something like, every year, the car travels 1.34 kilometres less far on 1 litre of fuel. Or something along those lines. D, estimate the distance the car would have travelled when the tyres were 3.5 years old. The first thing we'll have to look is 3.5 within our data range? So yes, it is, because our age goes from 1 to 6. 3.5 is between that, so we can do this estimation. Remember, if it wasn't between those data values, we wouldn't be able to. And it's just as simple as putting 3.5 into our equation. And you work that out and you'll get 16.6 kilometres. Last example. So you can often find 2 different regression lines depending on which variable you wish to approximate. So before we found the y on x regression line, so we can estimate y, but you can then do an x on y regression line to approximate x. And unless the regression is perfect, or the correlation between them is perfect, you'll get two different equations. So we'll show it here. So in this example, the scores marked out of 10 for a class of students in English and TOC are this. Find the regression equation of y on x. Find the regression equation of x on y. Show both lines in a scatter plot. Find the predicted TOC score for a student who scores 9 in English to the nearest whole number, and then find the predicted English score for a student who scores 8 in TOC to the nearest whole number. So the first thing we need to do here is go back to our GDC and work out our two regression equations. So to find the regression equation of y on x, what we're going to do is we are going to put our input into a spreadsheet again, which I have already done here. So English is x, and TOC is y. Now to do the regression equation, I'm going to show you a different way of doing it now, which is with the scatter plot. Once again, you can still go to your menu, stats, stat calculations, linear regression, put in your x and y, make sure your solutions are not going to be written or in column C, and here we go. So here you see it's held that M should be 0.763889, B is 1.91667. So another way you could do this, if you didn't do this part, is to actually do a scatter plot. So if I go to scatter plot here, now with the variables, we want y on x, which means we want our x on the x-axis, we want our y on the y-axis, and it gives us our scatter plot, and then we can plot a regression line. And when we do that, you see it gives us our regression equation here, and as you can see, that matches the values we were given when we calculated it. So you've got two options as to which way you would do it. So that will be your regression line for part A. For part B, we want the regression equation of x on y, which means we need the y on the bottom, and we want our x on the side. And you see here, it's changed our regression equation to match when we've swapped the variables around. So we'll go back to the notes and write that information down, and then carry on calculating. Okay, so here is a scatter plot that I did earlier for you for both these equations, and the green one is the equation of y on x, and the purple one is the x on y. Now question D wants us to find the predicted TOC score for a student who scores 9 in English to the nearest whole number. So 9's in our data range, so we can work this out, and we will use the y formula because we're trying to find the TOC score, and TOC is y and English is x. So y equals 0.764 multiplied by 9 plus 1.92, which gives us a value of 9, and that is rounded to the nearest whole number. And then for E, we want to find a predicted English score if you score 8 on TOC, so that will be x equals 0.902 multiplied by 8 plus 0.139, and that gives you 7, rounded to the nearest whole number. And that's it for this video, and that is the end of this chapter, so you can now finish your booklets.